You know, sometimes when you wake up in the morning and you think, I really hope today is a good day. I really hope today I get to do some calculus. If that's what you said this morning when you got out of bed, or this afternoon, or whatever this is that you're watching it, today's a good day because you get to do calculus. So let's do this thing. Okay, so now we're going to make some connections between f of x, f prime of x for polynomial and trig functions. So if we're doing this, and this is f prime of x, remember the derivative is also known as the slope of the tangent. So this is the slope of f of x. Okay, so if we know that this is the slope of f of x, I'm actually going to skip this one for right now. I'm going to go to this one. What I know is the slope of f of x is positive. So when f prime is positive, think about that for a second. The slope is positive, and in my mind I'm thinking like this. Mine's going to look different than yours. That's why I kind of turned, but I didn't really do a good job of turning the entire way. If I want to say the slope is positive, that means f of x is increasing. If f prime of x is less than 0, that means that f of x, so f prime, the slope is negative, is another way to say this. F of x is decreasing. So increasing kind of looks like this, decreasing looks like this. If I'm changing for f prime of x from positive to negative, so a positive slope to a negative slope, positive slope to a negative slope, at that value when it's changing, when it's neither positive or negative, I have a relative max or a relative maximum. That means when f prime of x is 0, that's what was going on up here. So if I'm talking about changing from positive to negative, this is a positive, or a possible, relative max, or it could potentially be a relative min, meaning relative to the things around it, it's the highest value on the graph, or relative to the things around it is the lowest. So it doesn't have to be on the entire graph. So if you look down below, like this is a relative max, this is a relative min, this is a relative max. And so if I look at one like this, when I have f of x, f prime of x is changing from negative to positive, that means f of x would be, it would have a negative slope to a positive slope. So this is a relative minimum. Okay, this, you're not going to be super happy about this because this is a lot of like just me. It's a lot of guesswork down here and you're getting close and approximating, but stick with me, particularly you perfectionist types. You can do it. Okay, so down here I've got this graph of f of x. And so I can see places where this function is neither increasing or decreasing. So like right here, what we say is this graph has a horizontal tangent at x equals 1, 2, 3, 4. And so over here at -4, so -1, 2, 3, 4, I want to make sure I didn't count wrong. 1, 2, 3, 4. That's where the derivative, the slope is going to be 0. Same thing here at x equals 1. I've got a 0 slope, which means it's actually like translating to a point of f prime being 0. And then if I go over here, 1, 2, 3, 4, 5, I think I can write 1, 2, 3, 4, 5. At 5, I have another horizontal tangent, or I can say that the slope is neither positive nor negative. So at 5, I would have a 0. So that's what it looks like on this graph of f of x. This is a graph of f prime. So I'm only just starting to do this. I can see right here that I've got, if I made a tangent line, because f prime, remember this is the slope of the tangent line. This tangent line isn't my best, but I'm going to go with it. And I can see a slope of 1, 2, 3, 4 over 1 maybe. So maybe like a positive 4. 1, 2, 3, 4, 5, 6, 7. That means at -7, f prime is equal to positive 4. 1, 2, 3, 4. If I go closer here at -1, 2, 3, 4, 5, 6, and -6, I can see my slope is like 1, 2 over 1, 2 maybe? Something like that. And then if I keep going, this one, oh, that's kind of a terrible tangent line. Whatever. 1, 2, 3, 4, 5, or down 3, right 2. So like 3 over 2, like 1.5. So at x equals -2, my slope is -1.5. So down here somewhere. Then I can see this one. This is kind of a crazy slope to draw. But I've got 1, 2, 3, 4, no, 3 over 1, something like that, like -3. It's kind of hard to see. But around here somewhere, we're not being exact, we're just kind of getting some points on this graph. We already did this one. If I had this one, this is a weird one to draw because you really could draw it on either side. This one actually is almost undefined, but that's okay. 1, 2, 3, 3 over 1 maybe. So at x equals 1, 2, 3, I'm up here somewhere. And then I can see I'm going to have this other negative value, and it's pretty steep. 1, 2, 3, -3 again, something like that. So at 1, 2, 3, 4, 5, 6, 7, did I count that right? 1, 2, 3, 5, 6, 7. Yeah, I think just because I drew a bunch of things. 7, it's negative something. I'm going to say around -3. And then I'm going to connect all these kind of nicely. This graph looks nothing like this one. I mean, kind of does a little bit. And this is just me guessing. You can see I totally went off that point there. Oh, gross. Did you hear that? My dog just coughed up something. So sorry. I probably should just delete this part. So, okay, do you see how this graph is nothing like this one? Or at least it doesn't have any like normal relationships that we would think about in other classes. Anytime this graph is above this x-axis, I can see that the function is increasing. So from here to here, like -infinity to -4, I'm sorry, not -4. Yeah, -infinity to -4. 1, 2, 3, 4. Do you see how this is where this function is increasing? Just because this is positive. Anywhere I go below the x-axis and I see something is negative over here, this function will be decreasing. And then again, will be positive over here. That means f of x is increasing and then decreasing. Okay, let's keep on going. Now you're going to try some of this. Sort of. At least you're going to think about it. And this one, it says approximate the value of f prime of -4. And I look over here and I'm like, okay, this is f of x. This graph is already so nice because it's labeled. So I've got this graph of f of x, and I want to approximate the slope of the tangent. Every time you see derivative, you should be thinking slope of the tangent at -4. So I'm going to go x is 1, 2, 3, 4. What is the slope of the tangent there? If I make a tangent line, the slope of that line is 0. Because if I use rise over run, 2, 3, 4, it would just be I'm rising, I don't know, 0, running 1. Rising 0, running 1. Slope of the tangent is 0. That means f prime of -4 is 0. And what values of x is f prime of -x equal to 0? Well, I've already said one of them. 1, 2, 3, 4. I want to make sure I'm good. Another one, f prime of x is equal to 0. We already said x is equal to -4. But then I would also say these other values. So x is equal to 1, x is equal to 1, 2, 3, 4, 5. And the reason is, you can see the graph is neither increasing or decreasing, nor decreasing. So I'm going to say as f of x is neither increasing or decreasing. Or you could say f of x has relative extrema, meaning relative extremes. Or you can say relative mins or maxes. That sounds weird. Maximums. Relative extrema. I feel like we're really fancy. You could actually say extremes also. F of x has relative extrema at those values. Okay, what I want you to do is think about what does f prime of x being less than 0, f prime of x being greater than 0 mean, and then try that. What are the places you think, what are those intervals for f of x? Okay, so f prime of x is less than 0. And I'm going to say f prime of x is less than 0 when, and I'm not even going to look at the graph yet, f of x is decreasing. And this is because this would just be the slope is less than 0. The slope is negative when f of x is decreasing. Same thing down here. You can say f prime of x is greater than 0 when f of x is increasing. And so down here I can say this one would be decreasing, would be from here to here. So it would be this interval, and you're going from an x value to an x value. So I'm going to say -1, 2, 3, 4. So I'm going to say on the intervals, so you know that I'm not talking about just a point, -4 to +1. And this isn't a union because it's not ever decreasing. 1, 2, 3, 4, 5. I could have looked up here too. 5 to infinity. It's really important to put it in parentheses, not in brackets, because this is at x equals -4, 1, and 5. F prime of x is not less than 0, it's just equal to 0. Okay, f prime of x is greater than 0 when f of x is increasing. So I look at the other parts of this and I think, oh, here's increasing, here's increasing. So I'm going from this occurs on the intervals and I'm going to say -infinity to -4 and 1 to 5. Can you even see this? Oh man, what was I doing writing down there? There we go. We're better now. I fixed it. As we always say in this family, and we actually do say this a lot, we say if you make a mistake, you do your best to fix it. Same thing if you have an accident, if you spill something. So common phrase around this house. Also, kind words, kind voices. That doesn't seem to apply here, but we say that a lot in this house. You always speak with kind words and kind voices. Okay, so if you were wondering on the last one, you're like, okay, I have a graph of f prime or f of x, but what happens if I have a graph of f prime? If you were wondering that, again, it is your lucky day because this is a graph of f prime. It's super important to label graphs right away because you don't want to answer questions thinking that you're looking at the graph of f of x when really you're looking at the graph of f prime, or vice versa. So right now, you actually know enough to go through and do this entire page on your own. So you should try it and then come back and go through the explanation as needed. So I'm going to do this now because, you know, I don't have to stop myself from doing this because it's a video and I'm going to stop you with Edpuzzle. On what open intervals is the graph of f of x increasing? I am going to write my explanation before I even look at the graph. I'm going to say f of x is decreasing because it says justify my response. F of x is decreasing when f prime of x, and now I'm thinking about this, f of x is decreasing when its slope is, negative. And then I'm going to say this occurs on the intervals. And if I'm talking about negative and positive, not increasing and decreasing, above the x-axis is positive, below the x-axis is negative. And you have to be careful that you're taking into account all the places where this graph is 0. So f prime of x is equal to 0 here and here. So I'm going to say on the interval -2 to 2 and 2 to 4. So -2 to 2, I know that f prime of x is less than 0. 2 to 4, also less than 0. This is going to be kind of crazy. This is the first time I'm going to use a bracket because at 4, the derivative f prime of x is equal to -2, which means I can actually say at 4, f of x is actually still decreasing. On what open intervals, oh, this says on open intervals, so I could have just left this as 2 to 4 also. Either one, because that would be on the open interval. It's just, this is more detail right now. Okay, f of x is decreasing. So I'm going to say f of x, did I just do all of this wrong? Silly me. Guys, do you see this? I just went through f of x was decreasing. Foolish. I'm going to put decreasing here because I can. And then I'm going to say increasing here because I can, but it was only because I messed up something and I don't want to rewrite all of it. Okay, increasing. I hope I didn't mess you up. Increasing, f of x is increasing. And I'm going to say when its slope, but I don't want to say its slope. I'm going to use the official math calculus language, and I'm going to say when f prime of x is greater than 0. I never want to say it or the function because I don't know which function I'm talking about, or it, what it is referring to. So when I'm going to say when f prime is greater than 0, and then I'm going to say this occurs on the interval. And there's only one interval because I just looked over my graph and I saw that. From here to here, this x value to this x value. So I'm going to say -3 to -2. Again, sorry I messed this up. This one I changed to decreasing, this one to increasing, but just because I didn't want to write it again. Okay, what values of x does f of x have a horizontal tangent? Think about this. Horizontal tangent means my tangent line, the place where the graph touches, will only, it has a slope of 0, the horizontal tangent. That means that f of x has a horizontal tangent, and I'm justifying when f prime of x equals 0. This occurs, and I'm just going to look up my function at x equals -2 and at x equals 2. Okay, next one. What is the slope of the tangent line? Wait a second, slope of the tangent line, what's that mean? It's derivative. Okay, so I'm going to say f prime of x, but it says at -1. So f prime of -1. If I go up to f prime of -1, do I know what that is? Well, it looks like it's right here, but I can't be sure until I actually check. But you see how if I go down to, right to, my slope is actually going to be a -1. So I actually know that this is a point, -1, -1. You can't just assume that, but we actually use the slope to figure it out, so we're good. Slope of the tangent line is -1. And I'm going to say slope of the tangent equals f prime of x. Like, that is my reasoning. I guess I should show it to you. Slope of the tangent equals f prime of x. Okay, last one. What is the slope of the normal line? The normal line is perpendicular. It's the line perpendicular to the tangent line. So I'm going to say the slope of the tangent line at x equals 4. And remember, slope of the tangent line is where f prime of 4, like slope of the tangent is the derivative. F prime of 4 is -2. Slope of the tangent line at x equals 4 is -2. And it's because f prime of 4 is equal to -2. This point is from the graph. So I'm going to say the slope of the normal line is +1/2. We did it! Guys, we're done so soon. Should we talk about other things, about life? What is life? No? We shouldn't? I should just let you go so you can have the rest of the day? Okay. Thank you for working. I appreciate you, and I'm so thankful that I get to teach you. Have a good day. Bye.